Hello, welcome everybody. My name is Steve Boggs. I'm the Dean of Physical Sciences here at UC San Diego. I want to thank everybody for coming. So UC San Diego is known worldwide for our faculty, our research excellence, and our brightest students. But we also have an incredible community that we're part of here in San Diego, and we're grateful for it every day. And so whether you're a student, a professor, alumni, or community member, thank you for joining us here today at this special event. So on behalf of the Division of Physical Sciences and the Arthur C. Clarke Center for Human Imagination, welcome to our discussion. It says presentation, but this is really meant to be a discussion, so I know our speakers are looking forward to lots of questions from the audience. So joining us today are Freeman Dyson and Gregory Benford, and their presentation is going to be on foreseeing the next 35 years, where we will be in 2054. And this is following on George Orwell's groundbreaking novel 1984, where Isaac Asimov looked forward another 35 years to 2019 to predict the future of nuclear war, computerization, and the utilization of space. And here we are now in 2019, and it's our chance to look forward from here, another 35 years to 2054. And we're honored to be here with these great minds who will share their insight and give us a glimpse of what the future could possibly look like 35 years from now. So to introduce these living luminaries, please welcome Brian Keating. He's a professor of physics, an associate director of the Clarke Center, and he's a faculty member at UC San Diego's Center for Astrophysics and Space Sciences. So Professor Brian Keating.
Thank you, Steve. Well, it's truly an honor for me to be here tonight to welcome all of you, our guests, and our esteemed speakers tonight. I'll just say a few words about each one of them, and then we'll get on to a couple of prepared remarks, and then James will present the rebuttal to his brother. Whatever his brother says, these are twins up here, and being the parent of twins, I know how they get along. But first, I'll talk about the two panelists tonight, and then we hope to get a lot of interaction from you folks. We are live streaming the event as we speak now, and there are questions coming in from all around the world. So first, I'll introduce Freeman Dyson, who is truly a legend. He is now retired, which has cut back the productivity of the field of physics dramatically, but he was most recently and for the longest duration, a professor of physics at the storied Institute for Advanced Study in Princeton. He's made many contributions, but of course, one of the most notable is his contribution to quantum electrodynamics, a field that is actually behind most of the technology and greatest advances in physics in the last, I would say, 70 years, probably the most successful theory of physics, and that is judged by how quantitatively and precisely it's been tested. He's written numerous books about science and the general public, and when I was writing my own book, which I won't mention because I want to promote other people's books tonight, but I asked Freeman if he would be so kind as to write me a blurb, an endorsement. It's my first book, maybe it's my only book, now that I've got so many children running around the house. And he said, absolutely not. No, I have no time, and I prefer to spend my time tackling the vast stacks of books that I've already promised endorsements to. But I thought it was so genteel, and so I've actually memorized his polite rejection, and I use it now. Whenever I have to say no to something, I invoke the Dyson text. So again, more of his, but he's written so many books. Some are on sale out front, and I'm honored that 3 years ago almost now, he was here discussing his most recent book. Tonight he'll be available. You can ask him questions about his actual most recent book, which is a book of memoirs based on his letters to various people, luminaries, but the things that are more interesting to me are letters to his sister, his family, and just the intimate portrayal of the life of a scientist. Very, very wonderful book. He's a fellow of the American Physical Society, a member of the National Academy of Sciences here in the United States, a fellow of the Royal Society of London, and in 2000 he was awarded the Templeton Prize. for progress in religion. And in 2012, he was awarded the Henri Poincaré Prize at the August meeting of the International Mathematical Physics Congress. And just this year, he won a very prestigious award. I'm blanking on the name, for science fiction. Freeman, can you remind me what the award was this past May? Yes, it was an award for outstanding science fiction writing. Joining the two of us will be none other than Professor Gregory Benford, who is an alum of UC San Diego. He was born on January 30th, 1941. January 30th, I say. Does that ring a bell to anybody? That's today's date. It's his birthday. As I said, he is a twin, and twins are not always evil. And today he has one of his most closest collaborators, probably since before birth, actually, his brother James, also born on January 30th. James. And it's even James's son's birthday, Dominic. Greg has been a professor at UC Irvine since 1971. I've known him for about half that time. It feels like he's a true legend in our field, publishing hundreds of papers in the field: condensed matter, particle physics, plasmas, mathematical physics, and several in biological conservation. He's been called a young Freeman Dyson. I don't know, I just called him that. He's a novelist, a screenwriter. He's also written incredible books, Easter, The Berlin Project, and his classic novel, which is just a true classic, takes place in part in UCSD's physics department in the 1960s. So I cannot be blamed for that. That predates my life. But it's just such a treat to have the two of them here tonight. I have a bunch of questions I'll ask, but I really want to get questions from all of you for the two of them. So please let us welcome Gregory and Freeman Dyson. Thank you, Freeman. So,
it's always interesting to be introduced by someone for whom I have books older than you are.
Well, I am a cosmologist, so
I
almost
can't
everything.
be the young Dyson, anymore.
So it's been famously said by such brilliant luminaries as Yogi Berra and others that it's very difficult to make predictions, especially about the future. And today is entitled 2054, 34 years in the future, 35 years in the future. And the question of what the deep future is like, I think that's something on all of our minds. As I think maybe Woody Allen said, I'm very interested in the future. I plan on spending a lot of time there. And for you guys, I think I wonder. Well, first of all, when you think about the future, just an overall question. I asked you this when you did a podcast interview with me in the context of if someone is going to tell you, I have good news and bad news, which do you want to hear first? And you told me that your answer will determine whether or not you're an optimist or a pessimist. So first I want to ask both of you guys, are you net optimistic or pessimistic, not just about physics and kind of our day-to-day lives as academicians, but about the world in general? So Freeman, I'll start with you. Your microphone's over there. You may want to hold it, just in case.
I'm not optimistic about this technology.
Well, he's a theoretical physicist.
Good. So can you hear me?
Yes.
So well, I'm an optimist. And, I look at the world today, and it's amazingly how much nicer it is today than it was when I was born in the 1930s. It was, in the 1930s, of course, was the blackest time in the last 100 years, where everything was going bad. You had the Dust Bowl in America. You had Hitler in Germany. We had terrible pollution in England, where I was. And every time you went to London for a day, your shirt collar was black when you came home. The air was full of soot. It's the kind of thing, people have short memories, of course, but compared with the 1930s, almost everything has improved, and I see no reason why the improvement should not continue.
Mm-hmm. Greg?
I, too, am an optimist, though I can't evoke the 30s. I was born in 1941, so let's see. So by this date, I'm going to be, 113? There is, I believe, no man as opposed to woman in the world who is that old right now. Men don't, well, we wear out, just face it, Cherish us while we're here. I think everything is getting better, and the alleviation of the vast poverty of the 20th century is a work well in progress. Most of it's gone. If you travel widely, you'll see that in many, many countries. And of course, bad news always dominates the front page of the paper, which is why I always read, well, first the cartoons, of course. Right. Second, just to improve my chances that I'll see a picture of one of my friends in the newspaper, I read the obituaries. And it works.
Leads to optimism. So recently, there's been a lot of talk amongst politicians and obviously pundits in the media about humanity's prospects in the deep future, maybe extending beyond 2054. But we recently heard, even dire predictions about the next 12 years for planet Earth. And some suggestions have been popularized both by the two of you and by other scientists working here at Scripps Institution of Oceanography and elsewhere about how one could geoengineer the planet to protect against possibilities of impacts of global climate change and other things that may happen. So I don't want to talk about climate change per se, but I do want to talk about this notion of planet-wide engineering. First of all, does the planet need us to do that? I get the sense the planet will go on just fine, maybe even if we're not here, but do we have an obligation? And if so, is there really hope? And who would do such a massive undertaking as to engineer and tweak the planet to perhaps protect it, extend its longevity, et cetera? So maybe, Freeman, you want to start with that?
Yes, well, I'm against that. It is, to my mind, what we need to do is land management and ocean management, but mostly on a local basis. But I mean, we had a vivid experience this year of the wildfires in California, and I happened to be up in Oregon, and where we were enshrouded in smoke for about a month from all the fires burning, and it's been very bad. And we certainly have a responsibility and a possibility to improve things, but it has to be on a local basis. We have to understand the nature of the problem before we can try to solve it. Clearly, it is due to human activities. We are to blame, and we have to try to fix it. But it's not something you really need an international authority to deal with. It's best the people concerned are the people who live there, and we better get busy and do it. So I would say that's the kind of problem I'm most interested in. I would not like to have some worldwide international authority trying to organize that kind of remediation. The remediation is hard to do. We have to be prepared to make mistakes, to take risks, all the things that an international organization is not so good at.
I agree, particularly because the major problems that we have are largely local, and in fact, it depends on your definition of locality. The Arctic, for example, is 5% of the surface area of the planet, but it's also heating at a rate faster than the average of the rest of the planet. Antarctica is also heating more rapidly for reasons we do understand from large weather patterns. So if we're going to do something in the near term, and I predict that we will on a scale of maybe a decade, I advocate and did a lot of work for DARPA on the screening out of sunlight in the Arctic in the summer alone for 3 or 4 months, which you can use aerosols at the very lowest part of the stratosphere, which is only about 40,000 feet, and they rain out in 3 to 4 months. The point is that if you lose the Arctic surface ice, as we are rapidly, then it's a positive feedback on the system. You get exposed more dark sea, you absorb more heat, and the system just keeps running away. Antarctica is in a somewhat similar situation. And remember, the Arctic contains most of Greenland. And so the loss of the Greenland glaciers, which would be a catastrophe, can be perhaps circumvented by such a policy. It's short-term every year. By the way, it only costs about $250 million a year, which is a rounding error in anybody's budget. Maybe not Bill Gates. So I agree we've got to do local experiments of a kind we haven't done before, because obviously what we're doing is not working. And it has become more and more obvious that carbon restriction is a good idea, but insufficient. It's necessary, but insufficient to solve the problem. And it ain't working all that bad. You'll look at the curves, they keep accelerating. Indeed, the only major nation that actually has cut into its fossil fuel emissions significantly is the United States, in part because of wonderful California. By the way, I don't think we should secede from the Union yet. I'm from Alabama. But it's because of the introduction of natural gas instead of coal. And we're the only major exporter of natural gas, which is cutting into the coal production elsewhere, too. So there are all kinds of things you could do like this that are small scale but have big effects.
And do you think it's fundamentally a physics problem, an engineering problem, a political problem? We hear a lot. We had a recent, event where a famous paper was retracted or had to be retracted from the, basic front cover of Nature magazine. No, it wasn't one of my results for a change, but it was, it garnered in some people in the public this notion of, well, science doesn't know whether, or not this phenomenon is real. Scientists haven't decided and don't make good policy wonks. And so the question is, A, is it a soluble problem? Because if we can't solve it, that changes the calculation of how much you want to do for it. Is it solvable using the laws of basic fundamental physical science as we know it? Is it practical to implement, engineering, and is it politically palatable? Those are all separate, I think, and maybe equal questions that need to be addressed. And so which of those, you say you're both optimists, so I assume that you would say that all three of those can be tackled at some level. But Freeman, let's start with you. Do you think it's a political problem? Is there anything about the laws of physics that preclude?
Well, of course, it's all three, and that's the nature of the human species, that we've fiddled around with things on all different scales, and that's fine. That's why we get ahead and sometimes fall back. Nature designed us as risk takers. That's why we're different from other species, because we can take risks, and we do take risks, which is the only reason we evolved the way we have. So the one thing that I dislike about the title up there on the screen is it talks about predicting the future. And in fact, I don't pretend to predict the future. The future is totally uncertain. What we can do is to imagine the future so we have some notion of what kind of problems may turn up. What really happens, of course, is unpredictable. And the most important things are the things that are totally unforeseen.
Ray Bradbury once said to me that he didn't think we should try, we writers, to predict the future, but rather to avoid it. and that's why there's so much negative and dystopian science fiction. First, as we all know, it's easier. We have problem solved by being not solved. I agree with Freeman again. This is getting monotonous. But it's certainly true that we are the species, the only one on the planet, that moves forward by falling somewhat and then catching ourselves. No other animal uses such a risky locomotion. The safety first animals are on four legs, and look where it got them. So we've got to take risks. The really hard part of this problem is how to reduce the risk while you're doing something useful. And that's going to have to be determined, I think, first by some real experiments that look at alternative ideas, such as, say, shrouding the Arctic, or veiling, as the Europeans call it, the Arctic, to see if you can stop the retreat of the sea ice. You use small perturbations to see what the result is. You couldn't possibly think you could manage this giant system without doing some kinds of experiments. You can't do it all with simulations. I would also point out that, having brought up in a religious family, Episcopalian, that in Genesis, the Lord gives Adam and Eve the job of tending the garden. And the first injunction is to name the beasts, which is a form of biology. So, hey, we've got the contract.
Talk about job security. Wow, that's better than tenure. So talking about science, so in your latest book of memoirs and through letters, Freeman, you talk about the great scientists that you've had a chance to interact with, and one of the most touching kind of passages, but only in retrospect. We're talking about optimism and pessimism. And it said, the optimist builds the airplane and the pessimist builds the parachute, and you're talking about meeting Stephen Hawking for the first time and being, horribly depressed because he's going to die very soon. This is 1970, 71. Of course, he went on to live until just March of last year, nearly 50 more years. And you say the only time that you really felt, buoyed is when you're in his presence, and you could only be thinking about physics and energized by the passion of this delightful soul, as you talked about. So we have this notion of scientists, and I wonder if you guys could, sort of talk about, mentorship and sort of the role of heroes and mentors and the way that we think about this, in science. Science is sort of an oral tradition. It's passed on through the generations. And we have students, and those students have students, et cetera. And I wonder, throughout the years, how's your philosophy of mentorship been shaped by the people that you had the benefit of learning from? And then secondly, for both of you being so creative, how, in your opinion, is it possible to teach somebody to express the kind of creativity and so forth that you had in your career and imagination, as is the title of the center? So first, what were the biggest people or events that shaped your philosophy of being a scientist? And then how have you sort of inculcated that going forward to train people, to train the future generation of scientists?
Yeah, well, of course, I was very lucky to know Stephen Hawking. He was just an amazing human being, and he's also really an important thinker. He really understood black holes before anybody else. He had made major contributions to science. And I remember I invited him to Princeton, and it happened to be in the middle of winter, and I was very apprehensive. What is this poor guy going to do with his wheelchair? The streets are covered in snow, and how can he get around? Well, of course, Stephen arrived, and the day before in Princeton, the temperature suddenly changed from minus whatever it was to plus 50, and the snow rapidly melted, and he arrived with his wheelchair and was just happily running around the streets, and he had no problems. And then, of course, in those days, buildings were not user-friendly for people who were handicapped, but so we lifted him up and down the stairs, and he was always making jokes and keeping us happy. And another time when I met him in Tokyo, he was staying in the same hotel, and he decided in the morning he'd like to go for a walk, and would I mind to come with him? And I said, oh, that would be delightful. And so we walked through the streets of Tokyo with Stephen in his wheelchair, and silently, crowds of Japanese walked along behind us, and silently touching his wheelchair. He was an object of worship. He was a great spirit which the Japanese somehow instinctively recognized. And of course, Steve was enjoying that enormously and making jokes and generally living it up. He had also a gift for playing to the crowd, which is part of his character, which everybody enjoyed, which is something, of course, Dick Feynman also had, who was another mentor of mine. Dick Feynman, of course, was a totally different kind of a character, but he had the same gift of interacting with ordinary people, and he was just obviously somebody you wanted to know and were proud to belong to the same species.
Yeah, it's a great species, all told. I met Stephen Hawking in '76, 5 years after you. I was a visiting fellow at Cambridge, and Martin Rees invited us to King's College for dinner, and so my wife and I went, and the bursar directed us to this room. I didn't know there was private dining rooms there at the time. And so door opens, you walk in, there's Martin Rees, all right, but there's also Stephen Hawking and his wife, and Dirac and his wife. It was an interesting evening. I remember thinking to myself, it was something my father told me once. He said, you know, never pass by a chance to shut up. You know, you do learn more with your mouth closed. I discovered that myself. So Stephen was always a blissful light for me, indeed. I could say that some of the people who most influenced me were here at UCSD. Because my brother and I came here from the University of Oklahoma and had good physicists, but we didn't have the likes of Maria Geppert-Mayer, who taught me nuclear physics, and I did some calculations under her, and Norman Rostocker, whom I did my thesis with, who's generated the firm of Tri-Alpha Energy now, which is making great strides toward fusion. I learned a lot from him, straight from writing my thesis onward, and then I got him to come to UC Irvine, where we started the big plasma program. So the people like that, Edward Teller, I was a postdoc for him at Livermore. He was incredibly quick and could calculate seemingly anything, and also had a strange, warped sense of humor. He asked me to go swimming once, and I knew that he was missing his left calf, had been run over by a streetcar when he was a teenager. And so I showed up at the pool, and there he was in a three-piece suit. Whereupon he sat down in a chair, he stood up and then sat down and took off the entire suit to reveal that he was wearing swimming trunks, then took off his left calf and threw himself with one leg into the pool. You know, it's kind of hard to describe what the reaction is. But he did need help getting out of the pool. So one of the things I like about science is that it's got these great eccentrics in it, and also some non-great eccentrics. But I had an editor once say, you know, one of the things that people like in your novels is that you portray the personalities of scientists. And he said, most people think that they don't have any.
That's a stereotype. Yeah, exactly. So speaking of the stereotype of, you know, kind of disembodied scientist, there's been a lot of talk about the impact of artificial intelligence and what that may do in the future, both for good and potential harm to economies, to industries, et cetera. Some are even applying tools of artificial intelligence to put, you know, certain entities out of business, known as physicists, in that some of the work that we do can be outsourced, if you will, to artificial intelligences. And the question that I have is, are you worried about that? Are these things that concern and should concern society? I mean, they already are sort of being warned about by the likes of Stephen Hawking and Elon Musk as, you know, one of the great potential danger signs for all humanity's existence. So I'm wondering what you guys think about the prospects for artificial intelligence, both good and perhaps for harm.
Well, this has, of course, been going on for 70 years. We have huge numbers of people have been thrown out of their jobs. All the empty factories all over the country. This is a big problem, and it has been a big problem for a long time. It's not new, but of course it could get worse. And we really should be worrying about it much more than we are. It's a disgrace that we're not taking care of all these people who are losing jobs to machines. And it's a world we live in and which we will continue to live in. But it's not something big in the future. This is something real that's going on now.
True enough. You know, if you really wanted to get human level in artificial intelligence, you also have to invent artificial stupidity.
Yes.
Because in a way, it's a gift. It's called risk-taking, right? Look how many people died trying to fly on essentially hang gliding without the right aerodynamics, done right here. I had a conversation long ago with a good friend of mine, Marvin Minsky. He was very big on AI at MIT. And I asked him once, if you get human-level AI, will it have an unconscious? Because we do, and it's a very powerful source of ideas, or at least it is in my life, and I think it is in most people's lives. The unconscious part of the mind that mulls things over and suddenly produces things. I always say, you know, we don't actually have ideas, ideas have us. They arrive out of nowhere. You haven't figured them out consciously. And Marvin said, you know, he never even thought of that problem. And I said, the fact that our minds conceal from us a great deal of our creativity is a huge clue, and we don't understand it, and we certainly don't know how to program it. So I'm not optimistic that we're really going to get human intelligence and stupidity married into one entity that can do productive things for us right away. Routine tasks, yes, but the hard stuff is really hard. And I don't think, let's put it this way, theoretical physicists, I think, use computers a lot, but I don't think we're going to get put out of our jobs because of it.
So yeah, bringing that up and circling back to a comment I made earlier about this question of whether or not you can teach creativity. Can you teach it to a student, to a meat computer, you know, let alone teach it to an artificial intelligence? So along those lines, I'm fascinated by, both of you guys are so productive and you know, have such voluminous output. What is your creative process like? I mean, you guys are basically artists in a sense. Your father was an artist, I know. But how do you, what is your process? How did you guys come to be as prolific as you are while also having day jobs as professional scientists?
Well, I've been very lucky. I've always been paid for doing whatever I please.
Here, that's
So I can't speak for the average scientist. I've essentially what I do is write either on a computer or with a pen, and I always feel that, as you were saying, that it's the fingers that do the thinking. It's not the head. So somehow or other, I have to have the pen in my hand, and then it writes, and I see something interesting, and that I go on. But it is an unconscious process, and that's something we don't understand, and still, it works.
Yeah, I also said to Minsky after we tossed this idea around a bit, I said, we don't even know why we can't see the unconscious, except it's a very clear example of maybe you were not meant to try to lift the hood and work on this part of the brain consciously. I agree. I've been lucky enough to be able to get into a profession where you can do what you want and write what you want. I have a series of tricks I've used ever since I was a boy. In the evening, I don't just fall asleep. When I'm getting drowsy, I review in my mind or even read things about what I'm working on. Maybe it's a plot of a novel or a scene, or maybe it's a mathematical calculation, things like that. And then I go to sleep. And when I wake up in the morning, I don't open my eyes. I lie there and I review all the problems. And my experience is that about a third of the time, there's an idea there, free, while you're sleeping. Now, sometimes it doesn't work, but you get it for free. And I think you can consciously let the unconscious talk to you. And my own experience is that if you don't do that, it stops sending you notes. You know, it needs an outlet. It's just like anything else in a living system.
Do you sleep with a journal next to you, or a tape recorder, voice recorder?
Yeah, I did that for a while, and often I couldn't read what I'd written. Well, I didn't turn on the light. But one time I could read it, and it said, "Write down your ideas."
Signed, Dad, because he didn't want you to say them out loud. And then Freeman, for you, you mentioned in your book you were stunned maybe, was it to rise? That you, so just getting back to the craft that you employ as a writer, for this most recent book, you had the material sitting in, I think in your mother's house or in your sister's house, all these letters accrued from 1941, including one on the day of their birth, the Benford boys' birth. And so you compiled this. So I'm just summarizing this for the audience, perhaps, as another piece of advice to go along with the kind of the mental hacks that Greg just presented. Keep your letters, because you don't know when they're going to be, you may need them someday to write a book if you're so inclined. So I thought that was a wonderful piece of advice in your most recent book, Freeman.
Yes, actually, I got... The reason this happened to me was I read the Double Helix, the story of this Crick Watson discovery of the structure of DNA, written by Jim Watson himself. And I mean, this book is full of human details which are wonderfully described as all the people involved. It's a very personal story. The small bunch of characters who did the work. But he actually reports verbatim conversations and events as they happen from day to day, describing how this all works out. And so I happened to meet Jim Watson after I read the book, and I said to him how it was such a delightful book to read. How did he remember all these details? And he said, oh, that was easy. I always wrote letters to my mother every week, because at that time he was in England and his mother was in America. And so he wrote her these weekly descriptions of what happened. And so she kept the letters. So after hearing that, the very next day I wrote to my mother, and I was in America and she was in England, and I told her, don't throw away the letters. So I really owe that to Jim Watson.
That's true. I mean, one of my agents once said to me, keep your correspondence. Think about your biographer. Yeah, right. Keep your correspondence. Some fans would maybe like to buy it, and you may need it sometime to make bail.
Right. For an alibi. That's right. So I'm going to stop, writing down all my correspondence using Snapchat. Great. Speaking of intelligences, I want to move in a slightly different direction. I want to talk about two things, and then I want to start opening it up pretty soon for questions from the audience. But to provoke the topic, there's a couple of different conversations that are going on. You mentioned that you've been hearing about artificial intelligence for 70 years, and it certainly seems like things are speeding up towards the so-called alleged singularity. I remember programming on a very simple, 8-bit computer, the kind of question and answer game known as ELIZA, which was meant to be a very, very poor kid's version of a Turing machine back in the 70s, 80s. And at that time, it wasn't clear at all that you'd have things like that are so helpful as the Microsoft paperclip. I mean, I couldn't even have dreamed, but Siri, Amazon Alexa, and all sorts of other artificial intelligences that are built in and that even my toddlers will engage with on a daily basis. Seems like something is accelerating. Ray Kurzweil calls it the singularity, when this technological advance will be basically driven by these positive feedback mechanisms that Greg spoke about in a different context. But is this something that is just continued to be hyped up? And then an allied question will be something called the simulation hypothesis, popularized by several physicists lately that I would like to talk about with each of you. But first, on the question of really the singularity, is that something that you take seriously, or is it just more hype?
No, I don't. But I mean, it's one of those things that doesn't look reasonable to me, but I could be wrong. I mean, things happen, and we must expect to be surprised. And so there might be a singularity. I would be, if I was still around, I think I would be very surprised. But what's clear is that the details are things we just have to learn to live with. It's not a curable problem. It's What we are concerned with is two types of intelligence, with the human brain and the electronic machines. And they are basically different because the human brain on the whole operates as an analog computer. Analog means it deals with continuous quantities. We are our brains are mostly concerned with recognizing faces, recognizing speech, recognizing patterns of all sorts, comparing them with a huge library of experience in the memory. And somehow this is done with extraordinary speed, which we don't understand. And it's done, as far as we can tell, it has nothing much to do with digital computation. The electronic machines, of course, are totally different in design. They are enormously more precise. They have this incredible reliability and incredible accuracy. So they can do all kinds of things that we can't do. But on the other hand, they're not good at precisely pattern recognition and handling images and handling patterns spread over a whole area, looking at a whole scene. I mean, for example, our perception of music is something qualitative rather than quantitative. We feel music, and it's very much part of our nature, but we can't calculate it, and so much the better. We have, it's one of our gifts, which probably the machines will have to admit defeat. But anyhow, so we have these two kinds of intelligence which have to learn to live together, and we don't know what the problems really are going to be. So I think, I mean, the singularity is one possibility. I think it's much more likely we will have ups and downs continuing unpredictably as far as we can see.
I agree with that general picture. I recently listened to a piece of software that I think is probably on the web somewhere, which had been programmed to write like Johann Sebastian Bach. And I listened to some short pieces, and they did sound Bach-like, but it wasn't writing the Brandenburgs or the French suites or the Mrs. Limnas. It was putting out bits and pieces. So I expect there will be a surge in capabilities, but you will be continually surprised. God, I didn't think they could do that or this. But general intelligence is going to be much harder. I think it's going to be, in our lifetimes, an experience like having a really good, diligent, but largely inexperienced graduate student. Because you can't know what a new technology will do. And that's one of its advantages. I mean, historians know that, for example, alcohol was invented so that ugly people could have children. But it's had much wider influence.
Very true, yeah. On the subject of, kind of partnerships with, humans and so forth, I saw a statistic, Google was bragging that this algorithm has a 91%, success rate in identifying pictures of cats. And I was like, that's great. My 3-year-old has a 100% rate of recognizing pictures of cats. And then she proceeded to do something which, it was really the first time I felt empathy, for something that was inanimate. So we have a Roomba, going around the room sometimes cleaning up, and then she kicked it. I felt pain on the behalf of this little robotic Roomba, it has very simple artificial intelligence. I wonder what will happen in the future when we have true assistance in physical space and how people will react to that.
You think the Roomba will turn on her?
I hope not. I already worry enough as it is about vacuum energy. So what I'd like to... What I'd like to do now is to open the floor to questions. what we'll do is we'll have people sort of ask their questions, and then I'll repeat it so everybody can hear in the audience, and so for the benefit of the panelists up here. And I'd like a very broad swath of the audience from all different backgrounds, et cetera. Sometimes we get a few of my close friends and plants that are the only ones asking questions. So I'd really love to get a broad spectrum of questions today.
Some of your close friends are plants?
Yes, they are. Okay, so we will start it off. I didn't mean to scare off anybody, and I can ask questions for the rest of the hour, too. We'll start over here. You have the first question. You right there with your black shirt. Yep. Yes.
So I'm curious, going off of the idea of artificial intelligence and recognizing that it's entirely possible that in the next 35 years, the constant prediction being, in 30 years, we'll have conversational AI. It's like a fusion power. It's the technology of the future, and it always will be. But with conversational AI, supposing that it were to come into existence in the next 35 years, how would we recognize it, and how do you think that we should treat it, considering we may have difficulty discerning between an artificial intelligence and human intelligence?
First question. Tell me a joke I haven't heard before that works. Now.
Let's just repeat the question. The question is about the prospects for both recognition of a general conversational artificial intelligence, which I believe would mean that you could have a conversation with, and if it were on at a keyboard or something like that, you wouldn't know if you're talking to a human or not. More or less the Turing test. So that's the question. So what would be how would we solve that, and how would we interact with such an intelligence? Is that the question, or is it more recognition?
On empathy, because we often, human history is a record of failing to empathize with other people that are not precisely like us.
Uh-huh.
And as time has gone on, we've been trying to get a better understanding of who we are as human beings and what makes a human being. So in a similar sense, when we look at artificial intelligence, if we were to recognize it as
Will it have rights? Yes. Okay. So will artificial intelligences eventually be perceived on a common footing with a natural intelligence, a human intelligence, with empathize, the ability to empathize with it and be more feeling than when my daughter kicked my Roomba?
Yeah, well, it may or may not happen. I mean, either way, it's interesting, and it's certainly, I would regard that as quite plausible. That's the way things look, but I don't regard it as threatening, and in many ways it would enhance our lives. In other ways it would be boring, and we just have to take the good with the bad.
Would you ask an AI for help with your personal problems? I think that's an interesting barrier that would be hard to cross.
Right, exactly. Yes. Steve, start with Steve, yes.
Looking to the future, and one of the things that there's just a huge amount of stuff going on is life extension. We're here in the Stanford Bergen Institute, and that's a big part of what they're trying to do. Make people live a lot longer. Science fiction, that's like a key theme in both utopian and dystopian futures, because it could make inequality much worse, or it could lead to this utopian where people have worse diet. Any thoughts on how you would see the future as it relates to life extension?
After the
Can
death
we,
of-
I'll just repeat the thoughts
yeah,
about life
sure, yeah.
extension, and one of the dreams that also equally occurs in equal parts dystopian science fiction and in utopian science fiction is this implications of life extension, perhaps to permanent lifespan.
After the death of my first wife, I spent a good deal of money, a couple of million, starting companies devoted to just this. And in fact, have been just recently produced something that at least stabilizes Alzheimer's patients. But the key thing is, aging is the failure to repair. And until we understand the underlying repair mechanisms and manipulate them, we can't do a lot. That's why we've got to do a much better analysis of the genetic basis of our repair systems. which in the companies I started is arrived at by looking at long-lived animals that are artificially produced. That's a different pathway that hasn't been largely used, and I think it has a great prospect for the future because the other measures, kind of brute force measures, haven't been working all that well.
Yes, I always say that one of the worst disasters that could happen to humanity was if the medical people find a cure for death. And I'm horrified with the idea of a population which is getting older and older and leaving no room for the young to take over. So I'm definitely not an enthusiast.
Yeah, Aldous Huxley, after many a summer dies the swan, 1930s.
That's a little surprising,
Somehow
Freeman.
Death is something we have to live with, and if that's abolished, we're in deep trouble.
I think Feynman, though, just to take an opposite side, said something like, most scientists would want to live forever, if only to see the deep future of what science and technology will provide, sort of a sense of curiosity that he wanted to live forever, to see what kind of scientific creations would come about.
Well, you know, the forever part bothers me because if you simply look at the accident rate, you find out that if that maintains the same level, it's going to be hard to live more than 1,500 years. So, I'm just saying.
Well, you know what I want people to say about me in 100 years, that I look pretty good for a 150-year-old.
So does Lennon.
Yeah, he is well preserved. More questions from the audience. We'll go on this side of the room, looking around. Yes, okay, you, sir, with your hand up.
I wonder where you think we'll be in 35 years across the solar system. And will it be humans out there or more sophisticated AIs?
Everyone hear the question?
Well, undoubtedly, we will be exploring. Yeah, we shall be exploring all kinds of interesting places around the solar system and beyond. And it'll be done with instruments because they are much cheaper and more cost-effective. But of course, quite apart from that, humans also want to travel in space, mostly as international sporting events, which the public is always willing to pay for. So we should certainly, both humans and machines will be doing different jobs. The machine's more interested in finding out what's going on scientifically, the humans learning to survive. And both of them will certainly need to cooperate, and I look forward to that. It's a great prospect. And I think in 35 years, we should have got a long way before, much more, we should probably have made much more progress than we did in the last 35 years.
Yeah. Of course, it's going to be a while before we tune in for the Lunar Super Bowl. But
High-scoring game, to be sure.
Yeah, there's so many great things humans can do in not just zero G, but modified G, lesser G. For example, there's some reasonable arguments that if you're in the last third of your life, you might extend your lifespan just by being in only a fraction of G and stop imposing such an impediment on your circulatory system. So that means a rotating colony in low Earth orbit, for example. You're in space, and I'm sure there are different things. It's Robert A. Heinlein pointed out in the 1950s that if you filled a big dome and pressurize it beneath the surface of the moon, people with wings on their arms can fly. It's 0.18 G. So there are all kinds of fun things you could do, but mining of asteroids, I think that's inevitable in this century for certain metals, particularly, which we're running out of. But the machines, here's the good news, are going to do, with their AI tenders, a lot of the hard grunt work for us while we get to play and fly.
Speaking about life in space, so I want to talk, I'll take another question in a second, about aliens. It's always a hot topic, is the subject of aliens. Freeman and I have talked briefly about, the so-called Drake equation, And I'm wondering, first, Greg, what are your impressions about the prospects for extraterrestrial life in general, but then specifically of a technological format that we could plausibly engage in communication with?
Well, life generally is, I would expect, quite widespread, and my old friend David Bren points out that life in ice-capped moons, such as around Jupiter and Saturn, is maybe very common. The trick is that it doesn't have great prospects for sending us radio waves. But generally, for advanced intelligence, we should realize that star formation began many billions of years ago, earlier than here, because we live out in the boonies. The center of the galaxies has had time to develop civilizations much longer than we have, almost 10 billion years longer. We're only, 4.6 billion years on the block. So looking inward toward the galaxy is the place to look for artificial signals, I think. And my brother and I have written some papers about this strategy. You should look for flashing lighthouses, not steady communications, called beacons. So I think we've only begun in the big initiatives under the Breakthrough program to really look at the huge spectrum of artificial transmissions that might be flinging around the galaxy all the time. So we've just scratched the surface. In fact, the amount of data processed by the Breakthrough Initiative in the last, what is it, Jim, 3-4 years, is larger than the total amount of SETI observations done before.
If you want to just, for the audience benefit, I know your brother works on it, but he doesn't have a microphone, so you have the chance to explain what the Breakthrough Initiative is.
Breakthrough Initiative is funded by Yuri Milner, a Russian billionaire living in Mountain View, who has started several programs to push forward things he thinks are a good idea but underfunded, such as the search for intelligent transmissions and also the development of really advanced spacecraft, even starships, small little things about the size of this, powered by a beam to go to other stars, to really break through the whole speed principle. I think the major impact of that second program is going to be to develop great, efficient means of sending things around the solar system better than rockets. But the point is, it is an adventurous scheme, and each one of these is getting, what is it, 10 million a year just to do the research separately. Each program.
So, Freeman, would you like to say anything about intelligent aliens and so forth throughout the galaxy?
Yes, I think it is a real problem that we haven't seen anything yet. There have been very extensive listening programs, and in Princeton we had an optical SETI program done by our students looking for these flashes in the sky, which is a very cost-effective and easy way to look for aliens, and we never found any. It was a big disappointment. I'm still surprised every time when we look for the things and never find them. So the aliens, for one reason or another, are very well hidden. Or maybe there just aren't any aliens, and that's, of course, a sad possibility that it might happen that actually the origin of life is a very, very unlikely event. We don't know. We simply don't understand the origin of life. One of the big scientific problems, which we've made very little progress thinking about, but it remains as one of the big challenges. Anyhow, so I say 3 cheers for Yuri Milner. He's doing a great job. I support him, and I hope very much he finds something. But so far, we have always been disappointed.
You know, on the question of life, what bothers me about our current program is it seems to me the most obvious place to look for life is beneath the surface of Mars, because we know it had a wet, warm environment very early, much earlier than we did. And as the atmospheres and seas went away, it would have gone underground, because we know we've got an enormous microbial life sphere below our feet. And it's been there for several billion years, and it's afraid of oxygen. But We haven't explored beneath the surface of Mars. The easiest thing to do is send rovers into the over 200 caves we have already found on Mars. And that's a lot more plausible outcome than talking about drilling through 10 kilometers of ice on Europa, which ain't going to get done in this half of this century, for sure.
Before 2054. Question in the back, Tasheen.
Real briefly, Professor Dyson, could you tell us a little bit about the Dyson sphere and whether or not you saw the episode of Star Trek that showed it?
Can you, so the question is to Professor Dyson, whether or not he can describe Dyson spheres and if he saw the episode of Star Trek that involves such Dyson spheres.
I did see the Star Trek episode, and it was a good story, and it was fine. It had nothing much to do with my ideas, but it was fun. Anyway, the idea of a Dyson sphere is actually a misunderstanding. I was interested in searching for aliens who don't want to communicate, who happen to be, for one reason or another, silent. One way to detect them is looking for infrared radiation. It doesn't involve building a big sphere. They could be in any kind of a habitat. The point is the aliens would have to have some way of radiating away waste heat, and they would have to have a large exposed surface of wherever they were living, radiating away waste heat in order to survive. And we could observe the radiation of infrared. So I proposed that as a scientific project, and about 20 years later, it actually was done. The IRAS satellite, International Radio Astronomy Satellite,
Infrared astronomy.
Infrared satellite, was flown. It was a little satellite, a little telescope over the Atlantic, which observed the sky over several years and found about 1 million of these objects which had all the appearance of an alien supercivilization. But of course, that's not what they are. We know these objects, in fact, are just young stars which happen to be still surrounded by dust clouds. They're still condensing out of the dust, which is part of the normal process of formation of stars. So young bright stars have this appearance. They radiate copiously in the infrared and not so much in the visible. And that's what these things are. So as a search for aliens, this was a dismal failure.
Another fun fact related to my Roomba. I had the honor of having Freeman and his wife over for dinner not too long ago. We had my wife was showing off different household appliances that I'm known to use on occasion. One of them was a Dyson sphere ball vacuum, which then my daughter also kicked. I don't know what she has against vacuums. There was another question close by. Let's see. Still wanting to see other people asking questions. Okay, right here.
Were there not intelligent aliens out there familiar with our horrible human history? Might they not want to avoid contact?
Would intelligent aliens want to avoid humanity because of our treacherous, barbarous nature? I should say, yes.
Well, we can only hope they haven't been able to see our television shows.
Freeman, would they avoid us because of our penchant for killing each other?
No, that is quite likely. And I would say if there are aliens, they won't all behave the same way. I mean, it's ridiculous to imagine that they come to a universal agreement to avoid us. We should certainly expect some accidental contacts.
Way in the back.
So on the topic of intelligent life, I think invoking Clarke's third law, any sufficiently advanced technology would be indistinguishable from magic. Are there any modern technologies that you see evolving into magic anytime soon?
So are any modern technologies capable of achieving Sir Arthur C. Clarke's definition of advanced civilizations being tantamount to the appearance of magic. Any technologies now that you may see going forward will take on the appearance of magic, essentially.
Yes, that's very likely. And
What?
well, of course, the whole point is we can't imagine.
We can't imagine them, Freeman is saying. So
Good
yes.
answer, yeah.
Yes, Greg.
Yeah, you're being asked to imagine something, but by definition you can't. Actually, what I believe will happen is that we won't see how the interconnected and smart systems we're evolving will be able to do things that no one envisioned before. Years ago, I got in a building in London, someone showed me a street scene and said, pick out somebody, and I did. I picked them out, and within 3 minutes, the system could find out where that person had come from and moved through the London transport system and where they lived and who they were. That's a scary possibility. The point is, I didn't see that one coming. Neither did George Orwell.
Right there.
Will time travel be possible in 35 years or ever?
Will time travel be possible in 35 years or ever?
I bet never, but I'm willing to be proved wrong. I mean, the novel I said at UCSD, Timescape, is about communication backward in time, which is hard enough. Nobody travels anywhere. But the problem is it's probably going to be some exotic thing, as it was in the novel. It was tachyons, particles that go faster than light, and we know from special relativity can therefore transport in principle messages backward in time. I was interested in this because I'd published papers showing that it was not true. But what the hell? But the trick is you had to be able to receive that exotic thing, and if you haven't built a receiver, you can't get the message. It reminds me of a question a school teacher told me she had put to a class, said, if you could take one thing back to really surprise people in the past, 1,000 years ago, what would you take? And the number one answer was a radio.
No, I would agree with that.
More questions. Yes, very back, hand up. Yes.
So when scientific innovation and advancement within a certain field starts to yield negative effects that outweigh whatever potential positives we get from that innovation, is it still worth pursuing just for the sake of knowledge, and if so, why?
Is it worth pursuing technology that may be outweighed by its potential negative ramifications on society? Yes. Is that still worth pursuing things that may lead? You could think of genetic engineering, for example, other subjects.
But hey, did we see all the impact of what I said before about alcohol? No.
Yes, I mean, we can't avoid risks. You can try to mitigate risks, you can try to foresee them, but they will be there. And in my mind, one of the great advantages of this modern science is it is entirely international. Everything we do in science is done by the international community as a whole. We have friends, that's one of the great joys of being a scientist. We have friends all over the world, in China, in Australia, and even in Greenland. It ties the whole world together. Of all the enterprises we are engaged in, that is perhaps the one in which we can communicate most easily. We all speak the language of mathematics. We all we can agree and disagree about politics, but we agree about the facts and we agree about the uncertainties of science. And to my mind, the most important thing that's happening in the 21st century is that China is getting rich and China is getting important. And that's something we should welcome and something we shall welcome. But particularly the scientific contribution of China is already essential in science and will be more so as the century goes on.
Here.
In the field of physics, what unanswered question that may have a big impact on our future
see solved, or that you're most interested in seeing progress forward?
So what question in physics would you most like to see solved or answered, addressed in your lifetime?
No, the beauty of physics is it really doesn't matter much to human welfare. It's as far as humans are concerned, biology and medicine are far more important. And physics is a game which we love to play, but for the average citizen, it's not really going to change things much. But of course, I mean, I would say the capabilities of computers are probably the biggest contribution of physics to human welfare at the moment. It does make a big difference. The populations in Africa or in poor countries all over the world all have cell phones. And that's a big change. And that's something for which physics can take the credit.
Yeah, actually, if you want a scientific issue I'd really like to see solved, and it's a physics issue, it would be the origins and meaning and true nature of both dark energy and dark matter in the universe, because I suspect those are clues that we're misinterpreting at the moment.
Yeah. So along those lines, I'll take my prerogative as moderator to ask you a question about, is there an obligation, so you asked this question, I'll follow up on it, in your lifetime, there is an impulse, a compulsion that scientists have to want to see answers in their lifetimes, meaning we have to build ever larger, more expensive, more dramatic piece of apparatus, speaking as an experimental cosmologist in my case. So we want to build the biggest possible telescopes with the most number of detectors, with the most computing power, as you speak of. But is there an obligation to do that, now? So there are plans being discussed for a 20 billion euro experimental follow-on to the Large Hadron Collider in Europe called the Future Circular Collider. And I wonder, they've generated a lot of controversy because that's an awful lot of money. Couldn't you use that money to do better things and feed, 100 million people in the world? Are there things, is there an obligation, just because you can do something by applying money to it, do we have an obligation to do it now? And, is it justifiable to spend so much money on physics projects when there's so many other pressing needs in the world? Please say yes. Please say yes.
Well, I have strong opinions about that. My answer is no, that there are things that are reasonable to do and things that are unreasonable. And the point where I start to say no is when projects get so large that they are driven mostly by politics rather than by science. And I think that's true of the Large Hadron Collider. It was not a good investment, and it made one major discovery of the Higgs boson. That was fine. It was a great piece of work. We can give them credit for that. But compared with the cost, it's certainly not impressive. If you look at the alternative, which is underground passive detectors, the kind that they build in Japan and in Canada, they are in fact far more cost effective. They make unexpected discoveries. The Hadron Collider can only make expected discoveries because the background is so intense. They have to essentially program into the machine what they're going to discover, whereas in the case of the underground detectors, the Super Kamiokande in Japan and the what is it called, Snowball in Canada.
Snow, yeah.
These and they do make unexpected discoveries because they record every data that comes in, whether it's expected or not. Mm-hmm. So I think as far as future of particle physics is concerned, to my mind, the future should lie with passive detectors, not with accelerators.
Very good.
I agree with Freeman on that. Let me point out another such example, and that is in fusion, where the ITER machine in Europe keeps getting pushed further away at a higher budget, much like the Webb telescope, and it may not even turn in the next decade. Meanwhile, Tri-Alpha Energy, which was spun out of my group at UCI, but which I do not own any stock in it, Ian, is making real progress with another idea. What we need is more ideas and not giant hardware to push forward our present ideas. I mean, it's not the job of theory to see to it that experimentalists have no surprises, but we can't be led by theory alone.
Right. Good. I want to take a bunch more questions from people that haven't had their question answered. The very back with glasses on. Yes, sir.
Do you have any advice for an aspiring physicist?
Advice for aspiring physicists. Freeman.
Well, you can come to UCSD.
Yes, that's right.
I did.
I didn't pay him to say that.
Yeah, I mean, we all have different gifts, and the only way you can tell by whether you have what it takes is to get involved and join a group and find out whether you really enjoy what you're doing. And that's to me, the only advice I can give. I would say if I was starting afresh, I would certainly try to be a biologist. Seems to me at the moment the prospects for really interesting surprises are much stronger in biology. But astronomy also is roaring ahead. Astronomy is doing extremely well. It's all about tools. We have, in both biology and in astronomy, we have new tools which are not so expensive, which are making discoveries every week. And that's it's a much more rapid style of doing science than physics.
Mm-hmm. The first time there was afternoon coffee at the UCSD, except it wasn't UCSD then, it was UCLJ, La Jolla. They changed the name. You heard it here first, or maybe last. My brother and I were standing there drinking some coffee, and we met Freeman Dyson. Here's this guy standing next to us, and wow, Freeman Dyson. And then, to make my point, he turned and said, "Oh, would you?" And this is Leo Szilard. And I thought, gee whiz, the best thing to do in the physics department is to go to the coffee breaks. And in fact, I live in University Hills at UC Irvine, and it is a community of about 4,000 people, 4,000 extremely intelligent introverts who don't talk to each other enough, cross currents are few, and don't let that happen to you in physics. Meet people with different points of view, different subjects, become broad, because you can never do poorly if you look at the larger scale of problems, and that means knowing the people who are doing it.
Yeah, that is almost the exact mission statement of the Arthur C. Clarke Center for Human Imagination. It's very extremely emphasizing interdisciplinarity between all the different gifts that we have on campus. Time for a couple more questions. We'll start right there in the middle. So how can scientists or physicists specifically organize? So harnessing the power of the free maverick spirit of science.
I think I understand what you mean, and I point out that thinking outside the box, that old cliche, I mean, why are you in the box anyway, is mandatory, I think, in this time of great problems. About the expansion of the ocean, if you put up an aerosol screen, the opposite of what I said before about doing local experiments, around the whole planet, it would cost roughly $10 billion a year, and you would know to stop the thermal expansion of the ocean and the melting of the glaciers required only that you reflect back 2 watts per square meter more than the Earth does now. 2, that's a tiny effect out of about 1,400. And that's a simple scientific fact. But how do you implement that? Well, you start small, of course, in small areas. But until you look at the base cause and what's possible, you can't get any cumulative action at all. By the way, it doesn't require 200 nations, as Martin Rees has sometimes claimed, in order to agree to everything before you do something.
Yeah, there's also the fact that the real problem is the difference between the land and the ocean. It is when you have rising sea levels, it's very often much more due to sinking of the land than rising of the ocean. And the sinking of the land is something we can remedy. It's due to human actions. It's due to mostly pumping water out of the ground. And you could raise the land by pumping water back in. And so insofar as it's a local problem, it's probably, we can't deal with it much more cheaply by dealing with it locally where the cities are on the coastal regions where this problem becomes acute. But of course, the ocean as a whole is rising, but much more slowly. And it's not so, the costly effects are, in fact, in the big cities where the problem is mostly the subsidence of the land rather than the rising of the sea.
Maybe we'll take one more question from the audience from a region that has not been. Okay, over here, and then we'll finish up. Yes, ma'am.
Hi. So I noticed, or the observation is that you're both physicists, scientists, but you're also both award-winning authors. So my question to you is, what's your inspiration for your work, and what advice would you give to somebody who would like to nurture that skill or talent?
What inspires you as both writers and in the craft of writing, and what advice would you give to others in addition to some of the advice you spoke about earlier?
Use your experience. Try to write about it. You'll know it better than anything else you learn out of a book. And the simple advice is you have to be rigorous, write every day if possible, have a schedule, and let, as I described, your unconscious do all the heavy lifting while you're asleep.
No, I would agree with that. It's something that you have to work, and you never know whether it's going to work or not. And a lot of what you write will be thrown into the trash. But whatever remains, you have to be happy with.
Great. Well, with that, I want to remind the audience of a few things that are going on in the Clarke Center. The first is the podcast that we have, which is UCSD's first and best podcast. It's called Into the Impossible, and Freeman's been a guest on the podcast, and we'd like to get Greg on it as well soon, too. This episode, or this film from tonight, will eventually make its way onto our website, so see there. There's about 30 episodes so far. And then I want to bring to your attention the next two events at the Clarke Center will be on February 19th, so just in about 3 or 4 weeks, and then again on March 4th. And you can see our website, imagination.ucsd.edu, for more information. As you know, this event sold out, so all of you who are out there in television land, make note of that, RSVP early. And we're going to conclude tonight, after we thank with thunderous applause these two amazing intellects. We are going to have a book signing out front for the next half an hour or so. So please join us in the courtyard and join me in thanking Professor Dyson and Benford.